Your mind thinks it's about to die, and you paid for that feeling. Let's go, that's what. It's midnight. The lights are off. You're alone, watching a horror movie. Your heart is pounding. Your palms are sweaty. Every instinct in your body is screaming, danger. So why do you keep watching? Why do millions of people pay to be scared? The answer isn't in Hollywood. It's been buried in your brain for 300,000 years. This is the story of your ancestors' survival alarm, and how horror movies quietly hijack that same alarm. Stay until the end of the video, because after that you'll never watch a scary movie the same way again. Let's go way back, to a time when horror movie used to be real life, and being afraid kept you alive. The horror paradox. Here's a weird puzzle about the human brain. Fear is supposed to be unpleasant. It's your body's built-in get away now signal. Racing heart, tight chest, sweaty palms. Every part of it feels bad in the moment. So evolution should have made us avoid fear completely. And yet, here we are. Billions of dollars spent every year on movies designed to scare us on purpose. Haunted houses, roller coasters, ghost stories around the fire. Humans don't just tolerate fear, we seek it out. This is called the horror paradox. And for a long time, scientists were stumped. Why would a species built to avoid death deliberately choose to feel like it's about to die? The clue turned out to be hiding in plain sight. It's not about the fear itself. It's about what fear used to mean. For 99% of human history, fear wasn't entertainment. It was information. It was your brain's early warning system. A system built for one job, keeping you alive long enough to have children. Every ancestor who ignored a warning sign simply didn't make it to pass on their genes. But the ones who felt a chill down their spine, who froze, who listened, who ran, those are the ones whose blood runs in your veins. That jumpy, paranoid, easily startled ancestor, he's the reason you exist. So your brain kept that alarm system running. For thousands of generations after the danger changed, the predators disappeared. But the alarm? It never got the memo. And that's exactly what horror movies exploit. Your ancestors' alarm system. Let's go back 300,000 years. You're not at the top of the food chain. You're a soft, slow, clawless mammal. Lions, hyenas, snakes, they all want you dead. Every walk to the river is a gamble. Every rustle in the grass could be dinner. Yours or theirs. So your brain evolved a brutal shortcut. Assume the rustle is a predator first. Ask questions later. This is called error management theory. And the math behind it is brutally simple. If you mistake a stick for a snake, you waste 2 seconds of embarrassment. But if you mistake a snake for a stick, you might not get a second chance. So natural selection rigged the game. It made your brain overreact to threats. Better safe, paranoid, and alive, than relaxed, confident, and extinct. This wiring didn't just affect your muscles. It rewired what your brain finds fascinating. Ever notice how you can't look away from danger? A car crash, a spider crawling nearby, a dark hallway that just feels wrong. That magnetic pull toward danger has a name too. Psychologists call it threat vigilance. Your brain is designed to fixate on anything scary. Because in the wild, looking away could kill you. The ancestors who couldn't stop staring at threats gathered more information, reacted faster, survived longer. So evolution built you a brain that treats scary as important. Not bad, not to be avoided, just impossible to ignore. Sound familiar? It should, because it's exactly what a horror movie does. The slow creak of a door, the shadow that moves just slightly wrong, the music that tells your body something's coming, before your conscious mind even understands why. That's not a coincidence. That's 300,000 years of threat detection, being triggered by pixels on a screen. Your ancestors' alarm doesn't know the difference between a real tiger and a movie tiger. To your ancient brain, a scary movie villain and an actual predator trigger the exact same alarm bells. And that's only half the story. The amygdala and the fear circuit. To understand it properly, we need to go inside the skull. There's a small, almond-shaped structure sitting in your brain. It's called the amygdala. Think of it as your brain's smoke alarm. It doesn't think. It doesn't reason. It just reacts, immediately, before reasoning even gets a chance. When your eyes see something scary, signals reach the amygdala in milliseconds, faster than the thinking parts of your brain. That's why you jump before you know why. Your body has already moved, while your mind is still catching up. This is called the fight-flight-freeze response. And the moment it turns on, your whole body changes. Your heartbeat speeds up so blood reaches your muscles. Your pupils dilate so more light comes in. Your senses sharpen. Sounds seem louder. Digestion nearly shuts down. Who cares about eating during a tiger attack? Every system in your body focuses on one goal: survive the next 10 seconds. Now here's the most interesting part. This whole process can be triggered by something your eyes know isn't real. You can tell yourself, it's just a movie, and your amygdala won't listen. It evolved long before movies existed. It has no concept of imaginary. For your amygdala, a sudden frightening scene is a real attack. So your body reacts before the brain can object. But this is where it gets interesting. Right after the amygdala fires, a second system starts working. Your prefrontal cortex, the reasoning, thinking part. It catches up from behind after about half a second, and it sends the rest of the body one message. Relax. We're safe. That wasn't real. And that tiny gap between full terror and full safety is exactly what horror movies sell you. Real threat without real consequences. All the chemical fireworks with no actual risk. Your body doesn't know, it's just pretend. But deep down you do. And that's the difference where all the fun is hidden. Psychologists have a name for this whole phenomenon. They call it safe simulation or benign masochism. It means your brain can practice fear in a place where nothing can actually hurt you. Think about a roller coaster. Your body feels like it's falling toward death. Screams, adrenaline, clenched fists. But as soon as it stops, you laugh and you get back in line. Horror movies work exactly the same way. You know you're sitting completely safe on the couch, popcorn in hand, doors closed. Nothing can reach you. Still, your ancient alarm system doesn't care. It still goes off at full volume. And your prefrontal cortex is right there, slowly reminding you, we're okay, we're okay. That back and forth, alarm, then reassurance. Alarm, then reassurance, again and again. That's what creates the thrill. It's not in spite of the fear. It's because of the fear. Your brain releases a mix of chemicals. Adrenaline, cortisol, dopamine. The same rush a real chase would give you, only without the genuine risk of becoming someone's meal. That's why horror fans call it fun. Not fun despite the terror. Fun made out of terror. Researchers have found a surprising fact. People who enjoy horror the most often have the fastest fear responses. Their amygdala fires up as quickly as anyone's, but their brain recovers faster, and they enjoy the later chemical effects more. It's the same thrill sought by climbers, skydivers, and people who love plunging into cold water. Controlled danger. Real chemicals. No real harm. Liking horror isn't a flaw in your brain. It's running the very program that was built to run 300,000 years ago. Only one thing has changed. What's on the other side of the fear? Then, it was a saber-toothed cat hidden in the grass. Now, it's a monster on the screen. Same alarm. Same chemicals. Same ancient thrill. Only, the environment has become much safer. But wait, if this is the same in everyone, then why do some people love horror so much, and others can't even sit through it? Good question. The answer is personality. Researchers call it sensation-seeking. It's a trait that varies from person to person. Some brains crave novelty and intensity. Some prefer calm, more predictable experiences. Neither is bad. They're just different survival strategies. In old tribes, both types were needed. Bold people were needed to explore new territory. Cautious elders were needed to keep everyone safe at home. If everyone took too many risks, the tribe could be wiped out by carelessness. If everyone was too cautious, the tribe could starve from never moving forward. So evolution kept both traits alive in the genes. That's why horror movies split audiences cleanly today. Thrill seekers get more dopamine from fear. Their brains treat safe simulation as pure enjoyment. Cautious brains interpret the same scene differently. Their alarm fires just as fast, but the reassurance signal doesn't arrive as quickly or strongly. So the fear simply stays. It becomes anxiety rather than excitement. No response is wrong. They're just two settings of the same ancient dial. Age also plays a role. The desire for thrills peaks in adolescence and the 20s. Then it gradually declines with age. That's why horror marketing mostly targets younger audiences. It's not an accident. It's biology wearing box office statistics. There is also a gender pattern worth mentioning. On average, studies show men are slightly higher in sensation-seeking, whereas women often register danger cues on screen more deeply. But individual differences far outweigh the average. Many women love horror. Many men can't stand it. Your personal setting matters more than any group average. So if you like horror, you are not strange. You're running on the bold explorer setting. And if you dislike it, you are not weak. You're running on the cautious guardian setting. Now comes the part that will change forever how you watch horror. Every classic horror trick is directly tied to some ancient danger. Take something hiding in the dark. For 300,000 years, darkness really meant danger. No night vision, no streetlights. Just predators who could see you better. That's why dark hallways in movies still give you goosebumps. Take the silence just before something happens. In the wild, sudden silence meant a predator was nearby, because other animals had already gone quiet at the first sign of danger. Your brain still reads silence as a warning. Take things that move the wrong way. Crawling motion, twitching limbs, unnatural gait. Long ago, that signaled disease or something that wasn't fully human. Your brain still labels it instantly as stay away. Take masks, empty eyes, expressionless faces. Humans constantly read faces for threat or friendliness. A face that reveals nothing breaks that ancient radar completely. That unknown blankness feels deeply, instinctively wrong. Even classic horror music is doing an old job. A slow rumble sounds like a predator's low growl. A sudden loud chord sounds like a predator's lunge. Your body reacts to the sound before your mind has even parsed the image. None of this is accidental. Horror directors, without knowing neuroscience, have spent a century reverse engineering your ancestors' fear circuit. Every trick that just feels scary survives because it hijacks a 300,000-year-old survival tool. So the next time you're curled up watching a horror movie and your heart starts pounding for no real reason, remember, it's not irrational. It's ancient. You're not scared of a movie monster. You're feeling an alarm built for saber-toothed cats, doing its absolute best with the only tools it has. So